Okay, today's section, guys, is 1.2, addition of whole numbers. We're just talking about basic addition. We're going to start off with simple addition facts, which is about your addition table that you created. These are all of your addition facts, guys. If you don't know those by now, you can count by your fingers, or you can reference that table. The table is there for you to reference if you need to. You should know your basic addition facts, but if not, that's what the table is in your book for. Basic addition, guys. Let's say if we were to put here 4 plus 7 is equal to 11. Four plus 7 is equal to 11. Just some things. Not everyone knows this, but everything that you see here has a title. The 4 and the 7 are what's called your add-ins. The 4 and the 7 are what's called your add-ins. Those are the two numbers that are being added together. What's this called? It's that's what it tells you to do. This is your operation. Right, that's your operation. So out there we can have 4 plus 7, 4 times 7, 4 minus 7, 4 divided by 7. That's the operation. It tells you what to do. In this case, the operation is addition, so the 11 is called the sum. And some useless knowledge. Does anyone know what this bar is called?
The bar.
Starts with a V. The vinculum. Vinculum. Yeah. Like the fraction bar, the repeating symbol bar, the division bar. Yeah. This, it's all referred to as a vinculum. I have no clue why. Useless knowledge tidbit for the day. Okay. Some properties of addition I want to go over, guys. I'm going to go over some properties of addition. These are the same properties for subtraction, which we'll get to later. But the properties of addition. The first property is the identity property, or 0. The identity property of 0. It's called the identity property because your identity never changes. It remains constant. When you're born, you're the same person when you're born as you are when you die. So the identity property is the property that means that it does not change. It's the identity property of 0 because it basically says this. Adding 0 to any number does not change that number. Adding 0 to any number does not change that number. And we can do a series of examples just to drive home what that's saying. 2 plus 0 is equal to 2. 68 plus 0 is equal to 68, and so on and so forth. The identity property, identity never changes. It's called the identity property of 0 because if you add a 0, it does not change the identity of the number. So adding 0 to any number does not change that number. Now, the identity property is of 0. That deals with addition, but it does not deal with multiplication. Because if you multiply a number by 0, what do you get? 0. You get 0, so it does change that number. So, but we'll get to that when we get to multiplication. But that's the first property. Second property is the commutative property. What we're going to be doing, guys, is we're going to be doing some long addition problems. The commutative property, commute means to move things around. Commutative property says moving or changing the order, moving the order of the numbers does not change their sum. Moving the order of the numbers does not change their sum. Algebraically, it's written like this. A plus B is equal to B plus A. Might add that up here to the identity property of 0. A plus 0 is equal to A. Anything plus 0 is equal to about anything. Commutative property says moving the order of the numbers does not change their sum. So for an example, below this, if I said what's 4 plus 7, what's the answer? 11. Or if I said 7 plus 4, what's the answer? 11. Changing the numbers around, changing their order, moving them around, does not change the result of adding them up. Does not change the result of their sum. That's what the commutative property says. That allows us to, if I was to give you a long series of numbers, so, here's an example where we could use this. If I was to give you a series of numbers like this, 3 plus 6 plus 7. We could do, what's 3 plus 6? 9, and 9 plus 7 is 16. Or we could move things around. So instead of doing 3 plus 6 and then adding 7, we could do 3 plus 7, because that's an easy one. What's 3 and 7 add up to? 10. Right? We add 3 and 7. 3 and 7 make 10. So we group that into a group of 10, and then we add 6 afterwards. So that's an example of, if you're adding multiple numbers, the commutative property is what says you can regroup the numbers, you can add numbers and move them around to make it work out. And then the last property is the associative property, which kind of goes along with the commutative property. Commutative says we can move things around, so we could change this to 3 plus 7 plus 6. We can move the 7 and 6. That way we can add the 3 and 7 first and then add 6 afterwards. The associative property says grouping numbers. Grouping numbers differently does not change their sum. And we'll just go with this exact same example. Let's say if I had this. Here's an example. Let's say we had this. Let's say we had 3 plus 6 plus 7, where the 6 and the 3 have been grouped together. We can also rewrite it like this, where we're changing what's being grouped. So basically, you think about it, the 6 is reassociating who he's hanging out with. Instead of the 6 hanging out with the 3, the 6 is not hanging out with the 7. But it does not change the result. In this first example, 3 plus 6, what's that? 9. 9 plus 7 then makes 16. Over here, 6 and 7 make 13, and 3 and 13 then make 16. So we can group numbers differently, but grouping them differently does not change the sum. It's provided that every operation is addition. Okay, so couple ways you can do problems. Let's do addition of two numbers first. Without carrying. Let's just go over that first. Let's review how to add two numbers without carrying. Not without carrying. The addition of two numbers without carrying. Let's say we had this. 76 plus 43. 76 plus 43. We rewrite this using basic addition, so 76 plus 43. They have to be lined up based on the place value. So all of the ones have to be lined up, all of the tens have to be lined up, and so on and so forth. So if I was to change this to 431, and there was a 1 after the 3, the 76 would have to be shifted to the right. And we'll go with that. So 76 plus 43, what do we start with? The numbers on the left or the numbers on the right? Do we start with 7 plus 4 or do we start with 6 plus 3? So the first thing is we do 6 plus 3. What's 6 plus 3 equal? 9. So first off, we're going to start by adding your ones. So first you add the ones place value. You always start with the smallest place value. So add the ones place value. Now, I set up here the addition of two numbers without carrying. When we add 6 and 3, we get 9. That's still a 1. That's still a 1's place value. If this would have been 14, we'd have a 1's place value and a 10's place value. So this does not require us to carry anything. So then we move on to adding the 10's place value. So then add the 10's place value. Seven plus 4 is equal to 11. So we put 11. Now once again we'd say, well, that's our 11. Do we need to carry the 1? Well, there's nothing left to be added afterwards, so we don't need to carry the 1 in this case. We just bring down 11. All right, and here's an example of addition of two numbers with carrying. Let's say we had 3,846 plus 378. 3,846 plus 378. First thing you do is you line up the numbers based on their place value. So 3,846. And then directly underneath of that would be 378. The place values have to line up. Place values have to line up. So we would not line up to 3s because the one represents 3,000, whereas the other one represents 300. And then we'd go through and we'd do our addition problem starting at the right. We'd add the 1's place value first. 6 plus 8 is what? 14. Now in that number 14, which of the two numbers? In the number 14, which of the two numbers is the 1's place value? The 4 or the 1? The 4. So the 4 is what gets recorded below the 6 and 8. The 4 is what gets brought down below the 6 and 8. And then this 1 has to be carried over to the next place value because it does not represent 1, it represents a 10. So it has to be put with the 10's column. Now we have to add all three numbers. The 1 got moved to the 10's column. We already had a 4 there, so what's 1 and 4 make? 1 and 4 make 5, and 5 and 7 make 12. So we got 1 plus 4 plus 7 is equal to 12. Once again, the 2 is what maintains that 10's place. This 1 now represents 100, so it has to get carried to the next row. And then we have 1 and 8 is 9. 9 and 3 make 12 again. So we can bring the 2 along, and then this 1 gets carried. And then the last addition is 1 plus 3 makes 4. So if you look at this, guys, we have 3,846, 378. Those are our add-ins. And then our sum is 4,224. All right, and then let's say we have this. Addition of multiple numbers. Let's say we do 382 plus 469 plus 138. Two ways you can do it. We can use the commutative and associative property first if we wanted to. So what we could do is we could add up these two numbers, get that answer, and then take that answer and add 138. Or we could add 382 and 138 together and get that answer, and then take that answer and add 469 to it. It doesn't matter. If we were to do it that way, what would be the easiest two to add first, and why? I would agree with that. 382 and 138 would be the two numbers that would be the easiest to add up because 2 and the 8 make an even 10. Does that make sense to everybody? So if you're going to attack it that way, that would probably be the way to go. Add these two numbers up first, 382 plus 138. And then we just run through this exact same algorithm. We would do 2 plus 8. We add up the 1s. That makes 10. So we have 0 1s, and we have 1 10. So we have to carry that 1. Then we have 1 8 and 3, which makes 12. We write the 2, and we carry the 1. And then 1 3 and 1 add up to 5. So those add up to 520. That'd probably be the easiest way to tackle this because those two numbers add up to a relatively rounded number. So 520. Now that we've added those, we still have to add 469. So the best way to do this would then just underneath it here put plus 469. And then you just continue that same kind of process directly underneath. 0 and 9. Make 9. Does anything need to be carried there? Nope. 2 and 6. 8. Does anything need to be carried? Nope. And 5 and 4 added up make 9. And there's nothing that needs to be carried. So the final answer is 989. Now if the only thing you know is your basic multiplication facts, this is the easiest way to tackle it because it allows you to add numbers that are less than 9. 9 and under. 1 through 9 is all you have to add with a problem like this. Now, another way of doing this, so we'll call this method 1. Method 2 would be to add them all three on the same exact